We'll put that to one side and move on to this genuine one. Same problem with the power, uses that obsolete power connector. You find the genuine Hong Kong model, the cheap, because you've got the fake Hong Kong one, which you've just looked at, you've got the genuine Hong Kong, tends to have the type of connector that we can do the power leads for. But once again, we're just going to use pins for this to get ourselves out of the proverbial. We'll start off with PA. And we'll get as far as we can with transmit, and then I must go and do the post. I'm going to miss that tiny opportunity. The next post office is 7.5 miles away, so I go there twice a week. Right, power on, and here we are, channel 20, switch to PA, testing 1 2, testing 1 2 1 2, and there is more volume on PA than the fake version. I'm just going to spray that volume control because it's noisy. There we go. Testing 1 2, testing 1 2. That's much better. Right, we'll go over to the CB mode. Right. So this we've had a power supply in 25 amp power supply, 20 amp power supply from a gentleman not far from here, 4.5 miles away at Caythorpe, and we've lost his details, or not been given his details, because it was Stuart who passed the power supply on. I just want you to be aware your power supply has been ready for a couple of weeks, so if you'd like to contact myself or Stuart, you can have that back. Now I'm expecting this is going to be really good, but then the performance of the fake one was good, other than the squelch. So we can straight away tick off PA. I'm going to do the VCO. Let's have a look at it right now. So we'll go to channel 40. Need an earth connection. Put that to a coil. Far side of that capacitor. 3 volts. Press transmit. 2.45 volts is near enough for me. 1.1 and 1.5, that'll do. I mean, sometimes you see these with minus numbers and you think, what? So the receive VCO is the coil and transmit VCO is the red trimmer. So the test gear has now been on 40 minutes. So we'll go over to frequency counter and see if it's anywhere near on frequency. Well, it's not that far out. And if it doesn't go any better than that, well, that's still good enough. But it looks like there's plenty of adjustment left. Try and get it one above. Yeah. 2779. transmit power, we're on the 3 watt range. And it's not quite 3 watts, so it's 2.8 on channel 20. Channel 40, 2.8 watts. Channel 1, 2.8 watts. It's well balanced. This is probably going to be a candidate where the ballast resistor needs to be changed, because it turned, I mean, the ballast resistor in the fake one seemed to be more manned for the job than in the real one. But it's when I see bent cores like that I start to think, has it been fiddled with? Let's have a very quick look at deviation. Wallow, it's 3.5 on this test set, so that it definitely has been fiddled with. We'll verify that on the test set behind me, but we'll just do the transmit first. So we're on the 3 watt scale. That's in sensor position. That's now in sensor position. That was okay. So one of those was slightly out. It's now 2.9 watts for what that's worth. Nearly as good as a new set, isn't it? .9. Yeah, I think it's going to be a ballast resistor candidate. Oh, it's coming up a bit. It needs to, if it's not 3.5, I'll do the ballast resistor. It is 3.5. In fact, it's 3.7. Just go back on that one. Just check that that hasn't been fiddled with. Placement of these is precise. Yeah, say 3.8 to be honest. I'll just look at that one. Yep, so what we got on the other channels? Just not quite within the 0.1 that I want. Right, channel 1, 3.8, channel 40, 3.7, 3.75. So that's a good compromise. I should have done the current and I forgot. So what are we on now? 1.33. And the low power, which isn't adjustable on this model, is 300 milliwatts. Remember, it was 600 milliwatts on the Fate one. The power meter reads what when we key up? 1. Oh, we're on the low power, aren't we? Yeah, so that needs to come down a fraction. So remember, it's a relative power meter. So when it's on an aerial, it may read 2, may bang across, it's still doing the same power. Right. So we'll do deviation, and then I'll go and do that task. So I'll just plug into the quartz lock test set behind me. Wow, it's 3.5, yeah. Wow, there we go. Turn that off. And check it with the deviation meter built into the Marconi tester that I don't always trust. Wow, it's reading a bit low today. So that's now correct. So I'll come back in 20 minutes and we'll carry on. Well, the post office was actually open. So we'll get back onto this and see how this receiver's doing. Right. Plug the... Still got an attenuator on this speaker, so... Oh, I'm gonna plug it in the wrong one now. So I can hear that, but you probably can't. Right, we'll look at the oscilloscope and we'll see where the detector is. You know what, we ought to be running through the receiver and see how it is before we do any service work. So let's go to the cyanide meter instead. And yeah, well, it's very good. So it was 5, it's now 4. That is now 2.2 to 2.5 kilohertz. So deviation doesn't make you louder, it makes the signal wider. So up to a point it's going to make it louder, but once it gets to the correct amount, it then goes beyond that. And any radio with decent filtering, what happens is you just end up with it chopping off. So you get something like a grandstand base station, grandstand Gemini with really good selectivity. People are going to sound awful who are over deviating. Whereas somebody who's listening on a Fidelity 1000, which is as wide as a barn door, even if I love them and I can use them in this rural location, nevertheless they're going to sound better and louder if they're over deviating on a Fidelity 1000. So it just needs to be right, and the absolute maximum is 2.5. So if we've got 3.5, you're kind of causing bleed over on channels either side. So that's off my chest. 12 dB. We have a very good 0.3, I could say 3.6, I'll say 0.35. For 10 dB, .25, and if it will do 20, it's 1. Squelch. Now here we go. So squelch to full. that wants spraying as well. So right now we're at 27.5 microvolts for tight squelch. Now I like squelch to be 100, but not always on this chassis. Not always happens. Let's see where threshold is. I'll just spray that right now. Right. Let's go to the attenuator so you can actually see where I am. So we're parked at 0.3 of a microvolt. Switch the signal generator on because it's in standby. It's come straight in. Well, it did do. It's 0.45. Right, let's go through the... Oh, so look where the meter is. So at the moment it's showing S7 for 100 microvolts. So what brings it up to 9? Not that far out, it's 160 microvolts. Not applicable. Okay. Cleaned. And the sockets are okay. Right, let's see whether we can gain something on the receive. So with an S9 signal of 100 microvolts, we'll just do the detector, and it's hiding under the wiring harness just there. Wow, miles out. Good. Now we'll look at the cyanide and put that meter up. So we're keeping it down to about 4 dB so we're not saturating the receiver. That was spot on. That was spot on. The one I've missed, they've hidden a lot under the wiring on this set today. That was spot on. Just move on to the IFs. Good. Right, let's see what we've now got. Now, of course, having done the detector, we can sometimes get better sensitivity with the detector out. So let's hope it hasn't got worse sensitivity now that we've done a retune. That's pretty well 12. Ah, we're on the next scale. I'll have to go down a scale. Yeah, it has gone better. 0.26 now for 12 dB. For 10 dB, 0.22. For 20 dB, it's 0.98. This is 20 is just noise. It's just if there's hiss and that in the components, it really doesn't matter. And let's see where we are now with the squelch. And for this, we'll go back to the normal extension speaker so you can hear what I'm doing. Right, so let's see whether we can squelch out see if we can squelch out 30 microvolts. Yes. But we want it to open at 100 microvolts. So let's show you the attenuator. So at the moment it's too coarse. In fact, it's far too coarse. It never ever opens. It's a very fine line on these. That's too coarse. Still too coarse. I'm going to leave it at that because it did just open at 100 microvolts. Let's see what it says. It's 120 microvolts. So that's nice. See, we couldn't do that on the fake. The squelch is built into the LA 1422 IF subsystem FM chip. These were made by Sanyo really for stereo tuners. I've not seen them in two-way radios ever before or since, but Cybernet put them in their chassis. Nearly every component, semiconductor-wise, is Sanyo. Right, and at the other end of the spectrum, let's see where the squelch is. So, signal generator to standby, squelch to threshold, signal generator on, .53. So that's really nice. Now let's compare what we've got with the fake version. Turn the volume down. So, you know, we've got 3.954 watts out of the fake one. It's all down to that ballast resistor. It doesn't make any difference whatsoever. This isn't 2 foot less range than that one. It's exactly the same. It makes no difference. This is drawing a little bit more current. That was out of spec doing 600 milliwatts on low power. This is doing 300 milliwatts, which would have been legal at the time. It doesn't matter now anyway, because the spec's been superseded. No longer need low power. So spot on frequency with both sets. VCO is fine. Deviation setup fine. So here's look at the nitty gritty. So for 10 dB on the fake one, we've got 0.22. For 10 dB on the real one, we've got 0.22. For 12 dB, we got 0.26 and we got 0.26 on the real one. We actually got 0.7 on the 20, so it's actually less noisy on the fake one than it is on the proper one. But the big one is, even after modification, 27 microvolts was the best we could do with the squelch, which is like S4 to S5. Whereas at this one, we can squelch out just under S9. That's where I want it to be. So, no difference in range. It's just a squelch. And if they've already lasted 40 years, I can't see that the fake ones are that bad, especially by today's standards. Because I tell you what, if some of today's sets had been around in 1981, we'd have found out which the bleed-over boxes were, wouldn't we? One day I'm going to do comparisons of selectivity. I might end up having to be retired first because I just can't fit in setting up another test bench. So, where were we? We need to just do the S meter. So with 100 microvolts on the signal generator we don't want it to read S7, we want it to read S9. And there we have it. And we can make the plus 30 light. We were struggling with that on the fake one. We couldn't get better than 135 microvolts for S9. But when we did it on the air test, we did at least see the plus 30 light up. So this set, this Made in Japan one, works really well. It works as you'd expect it to work, and it sets up properly. That doesn't quite set up properly, but it still works fine. That's why I've done the two sets one after the other. We're done. So we'll just see whether the speaker works. We'll do an on-the-air test this evening, and then these can go back to the customer. So what we'll just do is we'll get the mics out. We'll just make sure the mics work. Ow. The sharp edges of the lid aren't as sharp on this genuine version as the fake one. So David was right about the squelch preset being different. So we've got 10K in the fake version, but in actual fact I altered it to 5K and improved the performance of the squelch. And that might be something to take on board. But considering the service manual says it's supposed to be 100K, we tried that and the squelch was even weaker. There's some fundamental differences, and there are, because all the coils used in the fake version are proper branded Tango ones, whereas all the ones which are in the posh version are Marvel branded. However they are. But they give me the impression of being cheaper. It's hard to tell, isn't it, with Far Eastern. It brings me to the brand LG, which is Lucky Gold Star. It's not Life's Good, which is the advertising tat. It is Lucky Gold Star. But to come out with that name in this end of the world isn't ideal. So they've dropped the Lucky and just call themselves LG. I mean, when I had the teleshop, we were taking Gold Star videos. They said LG in front. We knew it was Lucky Gold Star. We always did know that. But they don't seem to call themselves that at this end of the world. There was a particular country, and I forgot which it was, they decided they were going to start selling Jaguar motor cars. And in the first year, they sold none. And why was that? Well, it turns out that in their language, the word Jaguar meant something like unreliable or naff or something like that. So it was a silly name. You can understand why Toyota come out with bizarre names like Corolla and Nissan come out with bizarre names like, well, Sunny, Cherry. I had a Cedric. What about that? We'll take the Cedric today. Yes, Parker. Right. Get this on the aerial. It's about 11:30 in the morning on Friday. 19 Roger. We know how sensitive this set is. Nothing. I do continue to get rejected comments. The comments section is set up that, as you know, this channel is about UK legal FM CB radio. Now, some of the current models, as you're aware, which we've covered, are AM FM because we're allowed AM on CPT when using a CE approved modern set, not some old clunker. We never ever cover anything SSB, not even ham radio. It doesn't interest me. This is predominantly about these kind of radios, 2781, but we do cover other legal CB radios. And if people put a comment in about something which is outside of the scope, you know, like I'm using an Electrostatum Plutonimus Rex Mark II on CB. Well, your comment's going to end up in the sandbox, and I can't do anything about that. So it's got to be relevant to a legal UK FM radio. So there we go. Nobody to talk to. We'll have an on-the-air test later. Thanks for watching.